Hello, geometry. I just wanted to make sure that you understood if you want any more help on 10.5, 10.6 after looking at the homework or before looking at the homework or just want some more explanations, more examples of 10.5 and 10.6 type problems. I'm giving you those right now fairly quickly. So it's 10.5. So the first one I showed already, number one, was basically if the radius of a circle is quadrupled. Basically, it's multiplied by 5. If the radius is multiplied, or not by 5, sorry, by 4, then what happens to the area and the circumference? You ought to be able to tell us what would happen. And that means how much is the radius, or how much is the area and the circumference multiplied by? So what happens to the area and the circumference? So you just need to know your formula. A is equal to pi r squared. So if the r is multiplied by 4, then this is the original formula. So now you're getting a new one. So this is like the first area. This is the second area. So just sub 2 just to show that you got two different areas going on. Pi, and the radius is replaced by 4 times the radius, but we're still squaring it. So let's see what happens. Pi, 4 squared is 16. So it's times 16, and then r squared. And that 16 is multiplying by pi r squared. So your original area was pi r squared, and it's multiplied by 16. So area is multiplied by 16. That would be your answer to what happens to the area. So what happens to the circumference? Well, circumference is 2 pi times the radius, r. And so 2 times a pi, and now the radius is multiplied by 4. Now, since it's not being squared or anything like that, multiplication is what we call commutative. That means this 4 right here can also be seen as 4 times 2 pi r. This right here is the same as it was originally. So what happened to the entire circumference? Well, the new circumference became 4 times the original. So circumference is multiplied by 4. So the area was multiplied by 16, but the circumference is multiplied by 4. Okay, let's go to number 2. All right, so example number 2. If height of a rectangle is quadrupled. Again, that's just multiplied by 4, right? If it's quadrupled, what happens to the area? So what you have to realize is the area of a rectangle is just base times the height. And if we quadruple the height, then now we have a new area of base times 4h. And so the 4 comes out, and it's just 4 times the base times the height. So there's the original, there's the original. So area is multiplied by 4. That would be the answer. What happens to the perimeter? Perimeter. Well, keep in mind, if you have a rectangle, you have a base, height, and a height, right? So it's actually perimeter is 2 times the height plus 2 times the base. And if we're just changing the height to become 2 times 4h plus 2b, what you have to realize is a perimeter. We're going to get 4 times a 2h plus 2b. Well, there's nothing really happens here. This is being multiplied by 4, but this nothing is happening. And since it's a plus sign, it's undetermined. You can't do it. Nothing really happens as far as multiply by a certain amount or anything like that. Undetermined. Look at number 3. All right, find perimeter given 3 points. And let's just go ahead and get given 0, 0, basically the origin, 0, 6, and 8, 0. So you have to make sure you know how to plot these points. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So 0, 0. Now 0, this is x, y. So x is 0, and then up 1, 2, 3, 4, 5, 6. And that's the point 0, 6. Make sure you know that. And then 8, x, and y. So you go 8x, and then 0. But you want to find the perimeter of the triangle given, so I should have said of the triangle, given these 3 points. So notice what you have here. You have 6, you have 8. Now you could do the distance formula between these 2 points, but also you've got a right triangle. 6, 8, 10. Remember the Pythagorean triple is 6, 8, 10, comes off of 3, 4, 5. But if you wanted to, you could go 6 squared plus 8 squared, 36 plus 64, 100 equals, we didn't know the side right here. So x squared equals x squared equals x squared. Square root of both sides. 10 is equal to x. Much easier just to remember the Pythagorean triple. 6, 8 is the legs, then 10 is the hypotenuse. But we need to find the perimeter. So perimeter is just 6 plus 8 plus 10. 6 plus 8 is 14. 14 plus 10 is 24. And it's just 24 units, but I'm already just saying 24. And that's what's going on problems in 10.5. Just have to do the formula, use the formula. If you get in a bind, then just pick any number and plug in the change. And then divide. And I showed examples of that in the class video. All right, now we're on 10.6, the probability that we started in class. Remember, probability is what you want over the total. The trick on probability, and the thing that's going to be hard on probability, is making sure you do that correctly. For example, number 4, let's say example 4 here. We want to choose a point at random. And it's on this number line. A, B, is 10. And remember, if I say 10 there, it just is going from this point to this point. 5 and 15. So choose a point at random on this number line. What is the probability that it will be on, and I could pick A, B, B, C, C, D. Technically, I could pick, what's the probability that's going to be on A, D? Well, it's 1 because it's all of it out of all of it. But what's the probability that it will be on the segment CD? Well, if you look at segment CD, it's 15. That's what you want. Over the total, what's the total? The total you have to add up is 30. So probability is 1/2 or 50%, or you might even see it as a decimal sometime, 0.5. Okay, just remember to change decimals, 1/2 to 0.5, change to percent, you move the decimal place over 2 points. And that's number 4. Example number 5. Now we're going to watch TV. So we're watching TV, but we only want to find the weather, okay? The weather shows 5 times for 2 minutes. Every hour. All right. Well, we want to know is what is the probability of tuning in and catching the weather. So it's every hour. So the total amount of time is 60 minutes. That's the total. Okay. Well, weather shows 5 times for 2 minutes. So that's 5 times 2 is 10 minutes. Okay, that's what we want. So probability would be 10 over 60, or cancel out the zeros. Divide both the top and the bottom by 10 is what you're actually doing. And you get 1/6. So the probability is 1/6 if it said leave as a fraction. So 1/6 is the probability of, but now notice this is tuning in just one time. If I just tune in randomly at one time, then its probability is 1/6. What if I tuned in 6 times in an hour? So in an hour, what if I tuned in 6 times in an hour? What's the probability that one of those times I will get what I want? Well, here's one time. I want to do it 6 times. So you take the probability, 1/6, and you multiply it by 6. So you will get 1. So actually it'll say, what if I tune in 6 times in an hour? How many times should I expect to catch the weather? 1 time. Because you take the probability, multiply the number of times you're doing it, 1 time in an hour. That's how many times I would expect to actually catch the weather. If I tune in 12 times, then I go times 12, and I should expect to actually find the weather twice during that hour. Hopefully that makes sense. Remember, email me if you have any questions when you're doing your homework. And then number 6. Number 6, I want to give you more examples of geometric probability of hitting a target. So let's say I gave the example. In fact, I'm going to give lots of these. Are just going to be a lot of examples, okay? So if I have a rectangle and I have a triangle inside that rectangle with the same base and the same height, it doesn't matter if I ask you to find the area of both of these triangles or find the area of this triangle, or the probability of hitting this triangle or the probability of hitting this one. It's always going to be 1/2 because of what I talked about in class, or 50%. And it doesn't matter what the numbers are, because see, if this was 4 and this was 3, well, what's the area that what's total over what you want over the total? Well, let's say I want this. Well, I'd have to go 12 minus the area of this that I didn't want, which the area of this is 4 times 3 divided by 2. So 1/2, 3 times 4. Okay, 3 times 4 divided by 2, 6. So 12 minus 6 over what's the total area? Is 12. So 12 minus 6 is 6 divided by 12, which is 1/2. If you look at it as a formula, this is B, this is H. Well, what's the formula for this? I'd have to go base times height. So all of it minus what I don't want. I don't want this triangle. I want to find these two triangles. So I don't want 1/2 BH. And then that's over the all of it, which is BH. But notice 1 BH minus 1/2 BH. BH's are like terms, leaves you 1/2 BH over BH. The B's cancel out, BH's cancel out, leaving you 1/2. So you can use it, just make up a number, and you can get the answer really quickly also. What if we had a problem like this? We have a square, and we have a circle inside the square. And I want to know what's the probability if I was throwing a dart to hit this part right here. In class, I said, what's the probability of hitting the circle? So it doesn't give you, it doesn't have to give you anything. You can do just like this. Now, what I advise, it might make it easier for you if you just make up a number, make it well where your radius of the circle could be 1. So that means the side of the square is 2. Okay. But the area of this is all minus the circle. And then that would be over the total, which is the square. So see, it's a kind of a roadmap. So all of it would be the square, okay, that square minus the circle. So the area of the square is 2 times 2 is 4 minus the area of the circle, pi r squared, which r squared is just 1 squared, which is 1. So it's 4 minus pi over what's the total? Well, what's the total area? It's a square. And so it just has an area of 4. Now be careful. I cannot do this because when can cancel? Tell me when can cancel? I can cancel when I multiply, but add or subtract, I dare not try. Okay. So this is actually the answer. It's going to give you the answer. And you just have to put in your calculator. And the way you put it in your calculator is parentheses 4 minus pi, close parentheses, and then divide by 4. Let's see if I can get that on the screen. Right there. 4 minus pi in parentheses, divide by 4. And then press enter, and it's about equal to 0.21460, and it keeps on going. So it might say round to the nearest percent, and you'd round to that. It might say round to the nearest tenth of percent, and you'd round to that. So we're going to say round to the nearest tenth of percent. That means your percent goes 1, 2, and that's the tenth of percent. So that's 6. You ignore everything else. The 6 makes that 4 go up to 5. So 21.5%. And if 21.5% probability of hitting this, then the probability of hitting the circle is 100 minus 21.5%. 100 minus 21.5%, and that's what we did in class. We found the area of hitting, the probability of hitting the circle was 78.5%. You could do that with formulas as well. Just say this from here to here is the radius, r. That would make this 2r. Okay, so let's just say the probability of hitting the circle. Okay, so I want circle area divided by the square, because that's all of it. What we want is a circle over the square. So it would be giving you a problem like this. What's the probability of hitting the circle? Okay, and so the circle area, according to the formula, is just pi r squared over the total area would be not 2 pi, 2r. R plus r is 2r. So it's actually 2r times 2r, or 2r squared, because it's a square. And that gives you pi r squared over 4r squared. And look, r squared on top, r squared on bottom, they're multiplied, so you can cancel them out. And pi over 4, when you round it, gives you 78.5%. Okay? So that's what you're going to need to know how to do as well. And I have seen those on the ACT. Let me know, let Mr. Shell know if you have any questions. Have a great day.